In this video, we are going to see Lorentz force. Let's consider either positive or negative charge. Let's consider the uniform magnetic field like this. Here, the magnetic field direction is from left to right. Positive charge is kept perpendicular to magnetic field. Here, no force acts on this charge when it is rest. When the charges keep moving perpendicular to magnetic field, the charge experiences force called magnetic force or Lorentz force. Similarly, the negative charge experiences no force when it is kept rest in magnetic field. But it experiences Lorentz force or magnetic force when the negative charge is moving perpendicular to magnetic field. Let's keep our right hand to hold either positive or negative charge like this. If this is the direction of the magnetic field and this is the direction of the velocity of the charge, and theta is the angle between magnetic field and velocity of the positive charge, then Lorentz force will act on upward direction like thumb direction. In the same way, for a negative charge, the Lorentz force will act on downward direction. Lorentz force is always perpendicular to magnetic field and velocity of the charge. Next we see the total force. Magnetic force Fm vector is equal to Q into V vector cross B vector, and the electric force is equal to Q into E vector, because charge is moving, so we will get electric force also. So total force is equal to sum of electric force and magnetic force. Substituting these values in this equation, we get this one. Taking Q as a common, we get Q into E vector plus V vector cross B vector. This is the total force of the charge when it is moving in the presence of magnetic field.